Hi everybody, this is Miss Peachy from your WCA Physical Science class, and today I'm going to be doing a lesson tutorial for Unit 4, Lesson 5, Building Electric Circuits. So this is on slide 3 of your lesson viewer. That's where we're starting. The first thing you're going to do is open up this first link. It says Circuits, and that's going to bring you to the gizmo. Okay, and I'm actually just going to reset this because I was already using it a bit before I started the recording. So the first thing you're going to do is pop down on this drop-down box here, and you're going to download the student exploration sheet. I just downloaded the Microsoft Word version, but you can do either. We're not going to write anything in this. You're just going to use this as directions, okay? So I opened it up in my Word document, and it looks like this. We are just going to be using Activities B and Activity C here, not Activity A, okay? So what you're going to turn in, going back to your lesson planner, or the lesson viewer, I should say, you're only going to be turning in this bottom thing that says Building Electric Circuits Lab. Now, actually I do have this on my website, so if you go to my website here, and you go to the Physical Science tab, and you scroll down, you will get to Circuits Portfolio, and this is the lab sheet in Microsoft Word. So that's the one you're going to want to fill in, save to your computer, and send into the Dropbox. That's the one that's going to go to me, okay? Again, I have that here, and this is what gets turned in. Now, you're going to use this in conjunction with that student exploration sheet and with the gizmo. But again, this is the only thing you're turning in. And there's some stuff on the gizmo you really just don't have to do, okay? Now, the only reason why you really need to use the student exploration sheet, which I'm going to try to bring up here as well again, is because it's going to tell you kind of how to arrange your circuits. So for Activity B, which is the first one, you're going to make a circuit that looks like this. So that can be done using the gizmo. So if I bring the gizmo up, I'm going to just mimic this design. I'm going to put a battery in place here, positive on top. Oh, my battery's the wrong direction. There we go. Kind of have to flip it around a little bit. It's a little bit kind of a pain. And then I'm going to put a little wire from that battery to a switch, which goes to a bulb. And again, more wire. Basically just forming a box here. Just click and drag. Mine's a bit bigger than the image. That doesn't matter so much, so long as you have all the components where they need to go, okay? My bulb lit, so my circuit's complete. Now I'm going to go back to the other lab sheet because that's really going to tell me what do I need to know. The first question says, in the first circuit you build, how does changing the voltage in a circuit affect current in the circuit? Well, I don't know that yet, but I'm going to show you how to figure it out. So first of all, the voltage is on the battery. I can put the voltmeter across the battery, positive on one end and negative on the other, and it tells me that I have a 10-volt battery right now, okay? So the first question says, how does changing the voltage affect the current? Well, to get the current, I need the ammeter. So I'm going to just chuck an ammeter on there as well, and it says my current is 0.67 amperes right now. So then I'm going to add another battery, there we go, to this. I can actually, I guess I'm going to have to take my voltmeter off for now. I was trying to figure this out before. But I just have to add another battery in series, so the positive ends of the battery are facing the same direction, and the negative ends are facing the same direction. Okay, so if I put my voltmeter across it, it tells me I have a 20-volt battery now. Okay, does that make sense? Because you're putting two of them connected end to end. And notice the amps are now 1.33, right? So again, I'm removing this voltmeter just to get it out of the way. I'm going to add a third battery. You have to make sure those batteries are added in series, okay? So again, if I put my voltmeter across here, you would see it's a 30 volt battery. But notice my amps are now 2.0. So now you have the information you need to answer this question. How does changing voltage affect current? We can see that. So second question is, what is the impact of adding more light bulbs in series? Well, again, I have not done that yet. So you're going to drag these light bulbs out there. And what I want you to notice is not just the impact on the bulbs themselves. I want you to observe, are the bulbs getting dimmer or brighter? Are they all changing the same, or is one bulb dimming and the rest of them not dimming? I mean, these are things to look for. But I also want you to check the effect on the volts and the amps. Is it changing the amperage to add another bulb? We can take it out and you can check it out, okay? So think about brightness, think about amperage, think about voltage. Okay, those are the things we can check. We can also check the resistance. We can put an ohm meter. But again, that goes across everything, right? Oh, you have to disconnect that. Oh, we're just not gonna do the the ohm meter. We don't need to have it in there. Okay. All right, so that's answering the questions from the first part, activity B. Activity C is parallel circuits. So again, we're going to go back to our student exploration sheet, and you are going to set up activity C's circuit to look like this. So we can go to this, we can just clear it off, and then you can create this circuit. And again, you're going to answer the questions on the lab sheet. What is the impact of adding more light bulbs in parallel? If I add more light bulbs, how do the light bulbs look? But also make sure you're checking that amperage. Here's a key for this one, ladies and gents, okay? Let me set up a quick parallel one for you. When you're checking out what the current is in a parallel circuit, it is very important that you're measuring it across the battery, okay? So I want you to put the amp meter here because the current you get there will be different from the current you get here, okay? But it's also important to move it around a little bit just so that you can see that, because otherwise you wouldn't even know that could happen. But when they're asking this first question, what is the impact of adding more light bulbs? Well, when I look at the current across the whole circuit, which is right across the battery here, and I keep adding more light bulbs, how does that change the current? Whoops. That's important. It's just something that people often are missing. If I'm adding more light bulbs in parallel, how does that affect the current in the entire parallel circuit? The only way to measure the current in the entire circuit is right across the battery here. If I put it across each one of the bulbs, it's different, right? The second part says, in the circuit, is current constant throughout the circuit or does it vary? This is where you need to move that ammeter around. Is it different in different parts? And how is it different? Oops, I keep changing. I don't want to disconnect my wire, okay? And then finally, you're doing the conclusion questions. If you go back to that series thing, you know, what characteristic was common throughout the experiment? So what changed as you added more bulbs? In the parallel circuit, what was the same throughout the experiment? What didn't change? No matter what you did to it, something didn't change, okay? By the way, one thing I didn't do here is I need to make sure I always hook up that voltmeter too, okay? So no matter how many bulbs I add, what doesn't change? These are things you need to explore yourselves, okay? By the way, here I have 4 bulbs in parallel. Now if I add a bulb here, these 2 bulbs are in series with each other, although like this bulb is in parallel with this group here. Does that make sense? So these 2 are in series with each other. So you can have a circuit that has both series and parallel going on. But in order for them to be considered truly only in parallel, you can only have 1 bulb in each potential pathway. And finally, your conclusion questions. Why would knowing the characteristics of a circuit be important in designing electrical circuits? So this is the part, ladies and gents, you're turning in. And again, use the student exploration sheet as a guide to answer the questions on the lab sheet. Okay? That's what makes the most sense with this. Okay, hopefully that makes some sense and answers any questions you may have. If you guys have any additional questions or concerns, feel free to give me a webmail message or you can give me a call here at school, and I would be happy to answer them. Have a great day.